I am Meenakshi from Rohini College of Engineering and Technology. Today we are going to see the topic RSA Public Key Cryptography under the course Cryptography and Cyber Security. So what is RSA algorithm? It is a public key cryptography algorithm. What is public key algorithm? Two different keys are used. One is for encryption, the other one is for decryption. So RSA is mainly used for exchanging the keys, and it can be used for digital signature and to encrypt the small blocks of data. They are the main three uses of RSA. As I told, its main usage is to distribute the session key, and you can use that session key in a symmetric key algorithm. And another more important thing is, so how RSA becomes strong means it is based on the fact that we cannot find the prime factors of large numbers. That is the difficulty in computing discrete logarithm. So this is the basic principle which makes RSA as strong. So now we will see the basic steps of RSA algorithm. So in order to do the RSA algorithm, we need two prime numbers P and Q, and P and Q cannot be equal. So the first step, we have to calculate the value of n. So n is P into Q. Then you have to calculate the value of pi of n. So the formula for calculating pi of n is P minus 1 into Q minus 1. After that, you have to choose one integer as the encryption key. Okay, one integer is selected as the encryption key. So the condition for choosing the encryption key is the greatest common divisor of pi of n and e should be 1. Okay, there cannot be any other value. If we find the GCD between pi of n and e, it should be equal to 1. And the encryption key should lies between the value 1 and pi of n. Okay, after choosing e, you have to calculate d. So you can use the formula de is congruent to 1 modulus pi of n. So such that we have chosen the value of e and we have calculated the value of d. So we can publish the public key pair, that is e comma n, and the private key pair is d comma n. So now we move with the encryption process and decryption process. If I want to send a message m to my friend, I have to use the encryption key, that is e comma n, and I can create the ciphertext by using the formula c equal to m power e modulus n. Once the ciphertext is created, it is transmitted to the receiver. At the receiver end, the receiver must use its private key, his or her private key, in order to recover the original plaintext. So the original plaintext is m. So m equal to c power d modulus n. So they are the basic steps. Now we will see with one example. So to start the RSA algorithm, we need two prime numbers. Let us consider we have taken P equal to 17 and Q equal to 11. The second step is you have to calculate the value of small n. So the formula is n equal to P into Q. So we are multiplying 17 and 11 and we got the value 187. Okay. So then you have to calculate the value of pi of n. So the formula for calculating pi of n is P minus 1 into Q minus 1. So P equal to 17. So P minus 1 is 16. Q equal to 11. So Q minus 1 is 10. So we will get the value 160. Then you can choose E. Mostly in the problem, the value of E will be given. If it is not given, then you can go with any number. Okay, it should be a prime number and it should lies between 1 and pi of n, that is 160, and the greatest common divisor between e and pi of n should be equal to 1. Okay, so now we have chosen the value of e as 7. Then you have to calculate d. So the calculation of d involves the formula de is congruent to 1 modulus pi of n. So here the pi of n value is 160. Okay, so we have to find out the value of d. So for that you can use one more formula, d equal to 1 plus k into pi of n divided by e. So now d equal to 1 plus k. For k you can go with 1, 2, 3 etc. We have to go from lower numbers. Pi of n value is 160 divided by small e is 7. Okay, so now first substitute k equal to 1. So d equal to 1 plus 1 into 160. So it is 160 divided by 7. So 161 divided by 7. 161 divided by 7. So it is 23. For the first number itself, we get the value of d as a full integer. So you can take d as 23. Sometimes while we substitute key, we won't get a full integer. At that time, you have to move with the other and other values. Okay. So after the publishing encryption key and decryption key pair, so encryption key pair, that is PU, it is 7, 187, that is E, N, and decryption key is D, N, that is 23, N is 187. Okay, so now we have calculated the private key and we have chosen the public key. Now we move with the encryption. So we are going to encrypt M. M value is 88. So what is the formula? C equal to M power E modulus N. So C equal to 88 power 7 modulus 187. So you can go with modular arithmetic. So 88 power 7 can be written as 88 4, 88 2, 88 1. That is 4 plus 2 plus 1, 7. Okay. Now we will solve each and every individual problem. 88 power 1 modulus 187. It gives you the answer 88. So how you have to calculate? You have to divide, you have to 88 modulus 187 is 88 because the number is less than 187. So the answer is 88 only. 88 power 2 is 7744 modulus 187. That is, you have to divide 7744 by 187. So you have to get the remainder. So it is 77. So again we have calculated 88 power 4. It is 132. So now using these t values, you can calculate 88 power 7 modulus 187 answer. Okay. So the answer is 11. So this is how we are solving the problem using the modular arithmetic. For decryption, you have to apply the different formula, that is m equal to c power d modulus n. So what is the value of c in the previous step? It is 11. Okay. So 11 is our ciphertext. So now you have to substitute 11 and the d value is 23 modulus 187. So this is the value what we need to calculate. So again you can apply the modular arithmetic operation. 11 power 1, 11 power 2, 11 power 4, 11 power 8. That is 1 plus 2 plus 4 plus 8. And again one more 8. So 23. Okay. So our aim is to calculate 11 power 23. So we have splitted the problem into smaller problems and we have calculated each and every subproblem value. Finally, you can combine the subproblem values to solve the final answer, to get the final answer. So when we solve the subproblems and when we combine the subproblems, we will get the original plain text. So it is 88. This is how we are solving the problem using RSA algorithm. So now we are going to see the applications of public key crypto system. As I told, it is mainly used for encryption and decryption, and it is mainly used for exchanging the keys, and it can be used for digital signature also. So we have 5 possible attacks in RSA algorithm. One is brute force attack, that is trying all the possible private keys. The second attack is mathematical attack, that is we are trying to factorize the large prime numbers. Third attack is timing attack, that is we are calculating how much time we required, the system requires to compute the decryption algorithm or to perform the decryption algorithm. The fourth one is hardware fault based attack, that is the opponent tries to give some hardware faults in the processor, thereby it generates the wrong certificates. Okay, and the final one is chosen ciphertext attack. So it exploits the properties of RSA algorithm. So with this we have concluded RSA algorithm. Thank you all.